Do you want to optimize your React component? Then this tutorial is for you. Hi everyone, my name is Yazan, and I'm an instructor at Integrify Academy. We upload new content on YouTube every Thursday. Today, I'm going to talk how do you optimize or improve the performance using useCallback, useMemo, and memo. So let's go. All right, so let's take a look how can we optimize our React components. So here are three ways: memo, useCallback, and useMemo. So let's take a look at what is the difference between them before we jump into the code. So when it comes to memo, it's a higher order component, that's one. And the idea of it is basically it prevents the re-rendering if the props are the same. Based on what? On a shallow comparison. Shallow comparison meaning that it will look into only like if it's a primitive, so hey, it's number one, for example, they are the same. Or if they are an object, they just look at the reference, if the reference is actually the same. They don't, the component doesn't necessarily look into what the object includes and if the actual values in that object has changed. And then we have thirdly, is it similar to a pure component, but for functional components instead of classes. So if you have been doing classes, then this is the same as pure component. Then the second one is the useCallback, and the idea of useCallback, it returns a memoized reference of the callback function. That's one, and the reference can be changed if one of the values in the dependency has changed. We're going to take a look soon enough on what does that mean. Lastly is useMemo. useMemo, it returns a memoized value. So here is the difference between useCallback and useMemo. useCallback returns a memoized reference of that function. Where does it live? Whereas useMemo, it doesn't really care about like what is the where the object or the function lives only, but it all takes care of the value that's been computed or returned from that function. So it memoizes the return value of that function, not the function itself. And it's used for calculating and like optimizing this like expensive calculations if you have any. And it's again the same as the useCallback. It recomputes when one of the dependencies is changed. And lastly is as we said, just small recap, because here's the tricky part between useMemo and useCallback is it returns a memoized value. Keep that in mind. Unlike useCallback, which returns a memoized function. Okay, so let's take a look into what do we have. So first of all, we have this application where and then I have a server running, and then basically our code here. So let's take a look at what do we have in the code. So we have an array of users, basically just a normal array, and this useCallback component. And that component, what do we have? We have basically handle re-render. The idea of it just to update the state, so we could simulate the component is re-rendering. So basically that's how React re-renders. The moment state changes, component re-renders. Second here we have a handle delete user. We're gonna take a look on what is that later on. But the idea here is we are returning a user list. So a user list is also a component that just basically loops through a user, and that's it. What are we going to have here? So first of all, by default React, if the parent component changes its state or it re-renders, then all the relevant children will re-render with the parent. That's all by default. That is how React works, unless you kind of bailed out some of the nodes, like, okay, don't render this and only render that. So what does that mean? You can see here we have a console log in the user list saying user list component is re-rendering. So let's here run an experiment. So now if I click on this button, it means I'm rendering the parent component. So here you see render 2 times, 3 times. So every time the parent component is re-rendering, the child is rendering as well. Even though the values, you see here, what do we have? We have a user array, and the user array is actually like, it's not even inside that function. It lives outside the component, which is the reference. It's still the same. But this user list component is basically doing a shallow comparison and so on. So how can we first of all fix that? So we could do a React.memo. So that's where you would use the memo function or higher order function or higher order components. And then if we now go back into the UI, let's clear this up and render again. You would see that it only render once. Let's refresh. So user list component is re-rendering when I click it, and it just only re-rendered once. So that first, what memo helped us with is basically just make sure that, hey, the props are the same, they have not changed. So basically, let's just keep it that. So let's not re-render. As we said, like by default, React re-renders everything. It doesn't care. Everything will re-render unless we cannot explicitly say, hey, do not. And one of the ways I say to use memo, it's the idea of memo, not use memo, is basically to, as we say, to do a shallow comparison, make sure that, hey, did the prop change or not? If it didn't change, then do nothing. And that's what happened. Prop didn't change. But let's take a look in what if we include a function here. So we have a handle detail user, and in the handle delete user, if we basically pass it to the so if we say handle delete and then we pass the handle delete user, and let's also get it here, and lastly we would pass it, I think let's call it handle delete, not delete user, and let's add it to here. So on click, user ID. Okay, cool. All right, cannot invoke a possibly undefined. Okay, I think I do have a, yes, just a second. We have a TypeScript here, so let me just get this out. Yep, now TypeScript is happy. All right, so right now what have we done is we basically just pass a function. So we pass a function from the parent to the children. So let's see what does this look like now. So now if I do click render, voila, boom. Did you see? So basically now once I introduce the function itself, once I pass a function, the child component is back to being re-rendering again and again. So what is it? What's actually happened? So if you do remember, memo, what it does, it basically, as we said, it compares, it does a shallow comparison to the props. And if the props haven't changed, then it means that do not render. But here, what is happening? Since the parent component, this one is re-rendering, what it means? It means that we are creating a new function for everything. So handle re-render is being created again. Handle delete user is also being created again. So which means that the reference of these functions have changed. And since React.memo, it does a shallow comparison, then say, oh wait, hold on, this is a different function. This is not the same function. So how can we tell React that, hey, this delete user is actually have been changed, so please can you memo-wise the reference for me? Like, can you do that? That's where useCallback is here. So as we said, useCallback is for memo-wising the reference of the function. So right now, this is the syntax. It takes a useCallback, it takes a callback function, and then that's the second argument takes a dependencies. And the dependency here is saying that it's empty, meaning that just like useEffect, hey, I'm not listening to anything, so basically I'm not going to recreate myself. The moment you have, for example, like render or any function or any variable, here, that basically kind of listens to, and if that variable changes, then the entire reference will change. But here for now, I don't really necessarily care about it. I'll just give it just do it once. So when I do that now, if I now click on render, you see that the component is not rendering anymore, the child component. Why? Because we were able to actually memo-wise the handle delete user. Cool. So let's actually take a look, and I have here some just basically a code for you so we could test. Let's see, do I have the same? Let me pass this first. Handle. Okay. We're going to do handle re-render. Right. So this callback. Let me just have then here use callback to this. Since this example is doing for handle re-render, or let's just basically. Let me just. I don't know why I'm feeling too lazy this morning. Let me just basically take this handle delete instead of handle 1, 2, 3, and 4. Let's do that. And this way. Cool. All right. So anyway, so what is this here is happening that we're using just useref. So we could, I wanted to basically just to demonstrate that, let's check the reference, if the reference is the same or not. So at the moment right now, if I click render, you see that function reference has not changed. That's basically a test. So we could tell that useCallback is actually working, for example. So, but the moment I remove useCallback from the handle user details, like remove that here, now you would see that when I click the render, it's saying function reference has changed. Click it again, function reference has changed. Function reference has changed. Cool. So that's basically about useCallback. It's very straightforward. And yeah, so let's move on to the second one, which is useMemo. And in useMemo, it's going to be like pretty straightforward. So what did we say the difference between useMemo and useCallback? useCallback, it takes a reference, it skips or saves or memoizes the reference of the function. But useMemo, what it does, it actually computes the function, and then the return value of that function, that one, get memoized. Yeah, basically it's the idea of it just to kind of avoid or to avoid this unnecessary kind of like expensive computation that you don't really need to do it every time and so on. So it's kind of the same. So let's take a look here. What do we have? So we have here a Fibonacci function. Don't really need to care about there, but some expensive computation, let's say. And that one is using useMemo. Let's, for now, what we do, let's basically at the moment, let's remove that and call that function. So let's keep it without a useMemo first, and let's see what does it look like. So if I go back to the UI, let me refresh here. You can see that right now, if I would click re-render, so now we are re-rendering the parent component. If I click re-render, do you see that the Fibonacci is running? Every time I'm re-rendering, this Fibonacci sequence is actually running, even though like the state is still the same, like the number of that goes to Fibonacci is still the same. We haven't changed the number, but the parent is re-rendering, which means everything should be recreated again, meaning the function, this Fibonacci function, should be computed again and again and again and again, even though the num haven't really changed there. We are only re-rendering the component in this case. So this is where you would need to use useMemo. So right now, if I would say just basically write useMemo, and the syntax is exactly the same as like useCallback. So we're going to have here so it's takes a callback function here, and the num as dependencies. Here we're gonna see how does here plays actually. So at the moment here, if I would save the file, and let's say I want to increment Fibonacci by it's 5. Then if I would re-render, you see now what's happened. See the difference here. Now, if I'm re-rendering, the Fibonacci function is not being created again because the number that I passed to it is still 5. So I still have the same value. Why would I need to recompute again if it's the same value over and over again? So yeah, let's just remove useMemo here to simulate. So now if I remove that, now every time I click re-render, boom, Fibonacci runs. Yes. So what else next? Okay, so later is basically the num. Let's take a look at what does this dependency mean. So when I say that the parent component right now is re-rendering, but it doesn't necessarily Fibonacci function compute again unless the one of the variables in the dependencies got changed, which is here the num, meaning that this state. So let's just demonstrate. If I would now click increment, you see that now the memoized values has been kind of like revoked, like invalidated, and now what we're going to do is we're going to recompute again so we can take the value. And now if we re-render, it's going to be memoized. The moment we change the number, then that's where the useMemo will recompute itself, so can memoize the value. Yeah, that's simply it, and it should be very straightforward. But so one thing you have to keep in mind, so as to wrap up, is do not just go crazy, optimizing React and all these functions. React by default is super fast, and it meant for re-rendering. So only think of optimization when you really feel like your application is like it's suffering, or you really have really serious kind of like a lot of things happening in your components. That's where you look into optimization. Don't look into optimization as a first solution. You go first in. No, look into it when you really feel like your component now needs to be optimized. It's good to write be noticed, okay, here this component could be in the future, could be optimized. It's good for you to kind of be aware of what are the bottlenecks, what could be the bottlenecks of your application, but you don't necessarily need to optimize right away. And yeah, a lot of optimizations, it might be costing you time for really unnecessarily advantage. But anyway, thanks for today, and I will see you next time.